Okay, so x plus a is equal to, if I solve it for y square, let me solve it for y square, that will be okay. Solving it for y square, let me solve it for y square. This is x into y square minus sign, plus sign, a y square equal to a x square, this is minus x cube. Okay, it is giving us y square common, x plus a equal to x square common, it is a minus x. Therefore y square is equal to a minus x into x square divided by x plus a. So what we see here, if I put x equal to minus a, the curve is 0. I mean y square is infinity. That means that x equal to x plus a equal to 0 or x equal to minus a, the curve is having asymptote. Okay, so that is one of the points here. And the points a0, a0, 0, 0, meeting points on the x-axis, and that x plus a equal to 0. Okay, y square is plus minus 0, or sorry, y is plus minus infinity. Plus minus infinity. That means at x plus a equal to 0 is an asymptote. X plus a is an asymptote. Then asymptote. Or x equal to minus a, the curve is having asymptote here. And x equal to minus a, the curve is having asymptote. X equal to minus a is an asymptote here. Okay. Let me now draw the curve. Or this y square equal to, here the value of y square was, we took x square common, it was a plus x, sorry, a minus x it was, and denominator was having a plus x. It was a minus, a minus x, right? Okay, this is the value of y. Now let me draw the curve. So let me draw it here. Above. So the curve will be off. Then let us find out the area. So curve is, this is the point A0, vertex of the loop here. The curve is passing through this loop, or curve is passing through the origin, passing through A0. A0 is the vertex of this. This is A0, let me write here, and this is A point. This is A point here, x-axis. This is origin O, and here asymptote at x equal to minus a. X equal to minus a is an asymptote here. This is minus A0, this point, but it is an asymptote. X equal to minus a is an asymptote to this curve. What we have to find out? Area between, so area of the curve and its asymptotes. Asymptotes, and this is the area we have to find out. First area between, the loop is separate thing. We have to find out area of the curve between its asymptotes. Find the area of the portion bounded by the curve, this and its asymptote. Okay, so that is asymptote and this curve. So this is the area here. Area, let me find out, of the curve and its asymptotes, or between the curve. Area between the curve, and its asymptotes, Okay, so is equal to this area O. Let me take A here. A are taken here. This is A dash here. This is B. Let me take. Okay, or this let me take B. This is A here. What is the area? Twice of this total area. This is twice of this area, upper area. Twice of area AOD. 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 This is upper area, twice of that area will give us the area of this between curve and the asymptote. So this is twice. What is area AOD? This is the curve here, equation of the curve. Value of pi we have to find out here. This is pi into dx. We will substitute. Limits are minus a to 0. Simple. Minus a to 0 here limits. Y dx by dx from this equation. It will give us twice minus a to 0. Minus a to 0 here. Because curve is passing to 0, 0. And up to this a, then we will put, if we have to find out area of the loop, then limits will be 0 to a. Simple. Okay, but here it is minus a to 0. But this is for asymptote and the curve. Now let me take y. So y is here x under root a minus x divided by under root a plus x. So this is dx. Alright, now substituting x equal to a sin theta. Okay, putting here x equal to a sin theta. Now differentiating it with respect to theta. So we get, what do we get here? Dx is equal to a cos theta d theta. Okay, a cos theta d theta. What are the limits here? Let me find the limits. If it is minus a, it is minus a here. And sin theta equal to minus 1, so theta equal to minus pi by 2. And at 0 it is 0. So at limit at x equal to 0, theta equal to 0. And at x equal to minus a, theta equal to minus pi by 2. It is minus pi by 2 here. Let me put. So at minus a, okay, now let me solve it here. But no space, so let me solve it here. Finally, answer is equal to twice limits minus pi by 2 to 0. Okay, this is a sin theta. This is x under root a minus x. This is under root a minus a sin theta. A minus a sin theta divided by under root a plus a sin theta into a into cos theta d theta. Okay, so let me solve it further. Twice, this is minus pi by 2 to 0. A sin theta. Now from inside, under root a and under root a from numerator and denominator we cancel out. It will be only 1 minus sin theta in the numerator divided by under root 1 plus sin theta in the denominator into cos theta d theta. Okay, now let me further solve it. So it will give us what area? It is nothing but twice minus pi by 2 to 0. Here it is a sin theta. If I rationalize this, rationalizing this multiplying by 1 minus sin theta into numerator and denominator. So rationalizing this, multiplying by under root 1 minus sin theta in the numerator and denominator, this and this, we multiply into a cos theta. This a and a we have taken outside. Let me take this twice a square minus pi by 2 to 0. And this is a sin theta. Sorry, a we have taken outside. Sorry, a and this a we have taken outside. So this is only 1 minus sin theta. Well, this is square root and this is square root, multiplying the same value will be cancelled out. Or this is under root 1 minus sin theta whole square. That means square root cancelled out. Divided by the denominator we have 1 minus sin square theta into cos theta d theta. This cos theta and this in the denominator under root 1 minus sin square theta means cos square theta square root and square cancel out, so this will be cancelled out by cos theta. Only these two values are left over. Now let me further solve them. So what is the final value of this? It is equal to twice a square minus pi by 2 to 0. Okay, so this is sine theta minus sine square theta into d theta. Now this value which we have calculated here, okay, so this, the equation of the curve in case of loop also will get the same answer on the same value, but limits will be only changed. This value which is of sine theta minus sine square theta d theta is the same value, twice a square minus pi by 2 to 0. If I change that, this is sine square theta is 1 minus cos 2 theta upon 2 d theta. Why? Since 1 minus sine square theta, or 2 sine square theta is equal to 1 minus cos 2 theta. 2 divided by this. So sine square theta equal to 1 minus cos 2 theta upon 2. This we have substituted here. Now let me solve it further. It is twice a square minus pi by, let me integrate now. Integration of this will be sine theta is minus cos theta, simple, and this is minus sine 1 upon 2 theta, 1 upon 2 theta, minus sine, minus plus here, that will be plus cos 2 theta, sine 2 theta integration, will be sine 2 theta, cos 2 theta integration is sine 2 theta upon 2, positive value, but minus minus plus, okay, so it's plus sign, and cos 2 theta is positive sine 2 theta upon 2, that means 4. Now in limits, these three are the integrations. Limits is minus pi by 2 to 0. Okay, so it will give us twice a square. Now in case of minus cos theta, the upper limit is 0. At minus cos 0 is minus 1, no problem. Because at pi by 2 it will be 0. Cos pi by 2 is 0. It is minus sine, but it is minus sine. Sine theta integration is minus cos theta. Okay, at 0 it is 0, but at minus pi by 2 this value will be plus pi upon 4. Because 1.2 minus sine, but in minus pi by 2, lower limit if we substitute it will be positive. Okay, that value will be, this minus sign, minus becomes positive, but this is minus pi by 2, so it will become negative again. In minus sign here. Now sine 2 theta, at 0 it is 0. So negative sign is coming, but negative sign I think is positive here. How it is positive? Minus minus plus, okay, we have taken. And sine theta is minus sine square theta. Okay, no problem. 1 minus sine theta. This minus sign is something different. Okay, let me take minus sign minus pi by 2. At lower limit it will be plus pi by 2. If it is this plus, I think is plus sign. But when we put the lower limit, it will be negative. But this is negative sign here. So this plus sign, I think this is plus sign here. Out, but it is negative 1 minus sine theta. It was whole square in the numerator. Okay, it was minus sine theta only. Alright, so this is, but this is plus sign in this case. For minus, this was negative here. But negative becomes positive when we put the lower limit. So this is plus sign. Okay, so this is final answer. So 2a square, or this is 2a square into pi by 4 minus 1 is the final answer. So area between the curve and the asymptotes is this value, 2a square into pi by 2 minus 1. Okay, it's final value. Now second part of this is find the area of its loop also. Now in case of loop, we have the limits 0 to a only. Here limits 0 to a only will be there. So this limits will be 0 to pi, 0 to pi by 2. Because this is 0 to a. Same answer will come out here. So here answer is, let me take the limits only are to be changed. Because when limits are, it was minus a to 0. Now it is 0 to a. 0 to a means 0 to pi by 2. Only this answer will be there. Area of the loop. Let me find out. Now area of the loop will be, or area of the loop is also twice of this. This is loop here. P, Q, R, S. Let me take out this is D, dx. Okay, so this is the same thing. 0 to a here, limits twice of this area. O, let me take this B, OB, OP, OPB, twice of OPB area. That means only the same value y is y dx. So the answer will be this. Limits are only changed. 0 to a, there was minus a to 0. Only this 0 to pi by 2 will come out. It is twice 0 to pi by 2, let me write. And the same value, this sine theta, type minus sine square theta will come out. Okay, so we have to substitute the same value of y from this equation, which was y equal to x in the root x, x minus a minus x upon a plus x in the denominator. So that was under the square root. Then we substitute the same value. So this result will be same in the numerator. I mean, the value of y is same. In this case also, in this case also. So this is the same value, but limits are only changed. This is twice of, again integration. Let me put it 0 to pi by 2, which is sine theta minus, this is 1 minus cos 2 theta upon 2 d theta. Okay, now again integrating, this is twice minus cos theta. Okay, this is minus sine 1.2 theta plus sine 4 theta, sine 2 theta upon 4. I'm sorry, sine 2 theta upon 4. Limits are 0 to pi by 2 now. Putting pi by 2, now it is plus 1, because when we put the lower limit 0, it will be plus 1. But there it was minus 1 only. This is 1 minus 2 into, 2a square it was here. 2a square will come out, 2a square. This is twice a square, finally answer. Let me write here, twice a square. Minus cos theta will become, at lower limit 0, it will be positive 1. 1 positive, minus sine. Pi by 2, upper limit is pi by 4. Another, this sine 2 theta when pi by 2 0, because sine pi is 0 and at 0 it is 0. This is the answer. And previously it was, I think, positive, this was negative. This is the only difference. Okay, that answer at pi by 4 positive, and this minus 1 was there. And this is the only difference. So this is the answer of loop. Second answer is this. Area of the loop is this, 2a square 1 minus pi by 4. And area of the curve and between the asymptotes was 2a square into pi by 4 positive minus 1. That was the only difference. Okay. This is question number 16. Now let me talk about 17th question. What does question 17 say? Let me check it. Question 17th now. Okay, so question 17th is question 17th. It says find the area enclosed by the curve this and its y-axis. Okay. The curve is x y square is equal to x into y square equal to a square into a minus x. Okay, and its y-axis and y-axis. Between y-axis and this curve. Okay, so let me draw the curve here. Solution. maybe its asymptote here by x will be the asymptotes of this y, because at x equal to 0, y square is infinity. So not y-axis, but it is y-axis is its asymptote. Let me know the solution. Now this curve is symmetric. This curve is symmetric about x-axis. Why? Because y is even power. As y is even power. Okay, let me change this marker. Y is even power, first point. Second point, okay, the curve is not passing through the origin, but its vertex will be a0. At putting y equal to 0, x equal to a. So vertex of the curve, okay, will be a0. This is the vertex here. Now y square equal to 0, if I put here, so that means it will be a, okay, two coincident tangents are there, that y equal to 0. But if I find value, let me solve this for y. Solving it for y square, we get y square is equal to a square into a minus x divided by x here. So what is this? At x equal to 0, y is infinity. At x equal to 0, y square is plus minus infinity, or y is plus minus infinity, sorry. Y square is infinity, y square is infinity, y is plus minus infinity. That means at x equal to 0, there is an asymptote. At y-axis is an asymptote. So at x equal to 0, y-axis is an asymptote. That's why it says that you find the area between the curve and y-axis. That means y-axis is working as an asymptote. So between asymptote and the curve, we have to find out the area. The vertex is a0, as we have just calculated. Okay. So let me draw. And at x equal to a0 is the vertex. Now if I substitute x greater than or x 2a, 3a, etc. beyond x equal to a, the curve is not existing. At x greater than a, okay, y square is negative. Y square is negative. So curve will not exist. Curve will not exist. Doesn't exist. Curve will not exist for x greater than a. Greater than a. That means, let me draw the curve now. With the curve here. Sorry. So curve will be here of this kind. Let me draw the curve. With the curve, this is y-axis. X-axis is this. Origin y dash x dash x. Where it is a0. Let me take this a point. Now here, from this curve, this is the curve here between the asymptotes. From a0, the curve passes at or meets the x-axis at a0. It says, but it is having asymptotes. The curve is having, and y square is okay plus minus infinity at x equal to 0. Y-axis is working as an asymptote here. This is a distance. 0 to a limits are there. Now if I find out area, this area, okay, this is PQ, total area. That means this is elementary strip we have taken. This is N, or let me take N this length is dx. So what is the area of the curve? So area, required area, let me take. So required area of the curve, okay, and its asymptote, or between its asymptote is equal to twice of this area. Let me write first in terms of value. So this is twice area of, twice into area of, or twice area OA. Let me take this C point or D point. Let me take. This is OAD, twice of OAD area. That means twice of limits 0 to A, 0 to A. Okay, and this is y dx here. Y will calculate, just calculate here. What is y? It will give us twice 0 to A. Y here is this value. So this is A, y square is A under root A minus x upon under root x. Okay. So this is A minus x here. Alright, so y equal to plus minus this value. So now let me substitute the value here. So after solving this question, what is that question here? Okay, so we can put A minus x equal to something, t here, or let x equal to A sin theta by substitute. So in the denominator we are having A plus A minus x, that we put in the denominator. That will be then substitute A minus x, we will substitute then A sin theta, okay, or t. It can be converted into sin theta. Now let me solve this equation. So what is the area? Okay, the area of this question is being taken as area of this curve Okay, so let us take x equal to, if I substitute a sin theta, that will give us something value, or let me put here x equal to a sin square theta. Yeah, this is a sin square theta. If I substitute, if I put here x equal to a sin, this is dx, sorry, y into dx. If I put x equal to a sin square theta, now differentiating it, this is putting x equal to a sin square theta. So differentiating it with respect to theta, we get dx is equal to 2a sin theta into cos theta into d theta. What are the limits here? Okay, at a it is 1, so sin theta is 1. That means at limits here we are finding out limits. Limits at x equal to a, theta equal to pi by 2, because sin square theta is 1, or sin theta is 1, a upon a 1, so theta is pi by 2, and at x equal to 0, theta is 0. So limits are here, these. So let me put them here. So finally, area will be y's 0 to pi by 2 limits. A constant which I have to take outside, let me take, and this is under root a minus a sin square theta divided by under root a sin square theta into, this is 2 sin theta, 2a into sin theta, sorry, this is 2a into sin theta cos theta into d theta. is the value of this a sin square theta, and dx is 2a sin theta cos theta, 2a sin theta cos theta d theta, and this is a sin square theta because x equal to a sin square theta you have substituted in the denominator. So if I take under root a common from the numerator, that will be okay. The under root a will cancel out from numerator and denominator both. So this will give us twice a square because this a and this a square are taken outside. 0 to pi by 2 under root a will come out 1 minus sin square theta in the numerator divided by under root a this, and sin square theta is square root, so this will be sin theta only. Alright, and this is 2 into sin theta cos theta d theta. So 1 sin theta cancelled out, only cos theta is left over. This under root a cancelled out. There is nothing but twice a square 0 to pi by 2. This is cos theta. While under root 1 minus sin square theta is under root cos square theta. Square theta and square root cancelled out. Square and square root cancelled out. So this is cos theta from this square root, and this cos theta is cos square theta d theta. Okay, and if I solve it by gamma function, gamma beta function can be solved. Let me solve it by gamma function. No problem. Okay, so let me check anything left. No, sin theta is not okay, nothing. But this twice is there. I'm sorry, this 2 is there, so this 2 to the 4. Here it is 4a square. Why 4? Because this 2 and this 2 is already there, twice of that, so this is 4a square cos square theta. So finally this value will be 4a square. Now if I take it as m is 0 because sin 0 over sin 0 is 0, so this will be gamma, let me write 1.2 because 0 plus 1 upon 2. This is 2 plus 1, 3 upon 2 divided by twice gamma 2 plus 2, that means 4 upon 2. Okay, this is the value. Let me solve it further. 4a square, and in the numerator we have gamma 1.2 into 1.2, gamma 1.2 divided by gamma 2 means factorial 1, that means 1 only upon 2 only. 2 to the 4 is twice, and this 1.2 and 2 cancel out, only pi a square. Okay, because gamma